All right, everybody. Different background altogether today. So I am remote, trying to get some stuff knocked out. Got a lot of big projects going on. Just this is my way of being able to focus. So, with that being said, got a little bit of a different setup. I've created some slides. I've got some troubleshooting procedures, and instead of me being at a whiteboard, just kind of talking this through, instead we're going to take this approach this way today. So we'll dive into it pretty quickly here. I don't see a need to spend a lot of time on it. So this is the first call. You can see your parameters. If you have any additional parameters, feel free to ask. Um, and let me get my phone silenced here. There we go. Okay. Feel free to ask if you need any other info. The complaint. The complaint is the system hasn't been cooling and it has not been keeping up with the load in the space properly. So on your thoughts, whatever you think may be going on, put that into the comments. Let's get a conversation started. And this is just an exercise on working through a troubleshooting process or the workflow on, okay, you walk up to a call, the customer's complaining that it's just not keeping up. We see a return error at 78. So that kind of justifies the complaint there. How's everybody doing in the chat? I see you there. Um, so what's your first steps? How would you begin to diagnose this? And one of the big things I'm trying to drive is you've got to start somewhere. You've got to decide on something. So looking at the parameters you have, what is the first thing you would start to look at, recommend, or do? And if anybody has any trouble seeing, I just want to make sure everybody can see the screen I'm sharing, where I've got the little graphic and numbers and the coils and stuff pulled up. If that's not visible on your end, somebody please let me know. It should be. Anyway, so yeah, what's your process? Um, what do you what do you start with? What's the first thing that stands out to you? How would you diagnose this? Again, the complaint is we're not cooling or it's not keeping up. The system is not keeping up with the cooling demand and we're getting warm, we're getting hot. Uh, what stands out to you in this example? Want to see some stuff kind of come through the chat there. So a couple of options. All right. On a high level, when we see this, some of the first thoughts we might have is, okay, what's our charge, right? So one of the big go-tos we have when we see a system not keeping up, customers complaining, is do we have a low charge situation? So we can work through that as the first example. Evap sat's low. Several people identified that. Got a high superheat. Okay, those are good things to point out. Now, what does it mean? So you've identified some numbers that don't look quite right. Take it a step further. Start assigning those numbers to something. What does that mean to you? So in a low charge scenario, a low evap saturation and a high superheat, you could assign that to a low charge. We have evap saturation of 28, a superheat of 30. Our supply air is only 65. It's not that much. Our space is getting warm enough that we're up in the 78. So we've got a fairly decent load in the space. But I do see some things that uh, do concern me. Now, there is some question on what does these acronyms mean. Okay, these are things that you really should start to learn and pick up on. ESAT would be evaporator saturation, and below that evaporator superheat. OAT is outside air temperature. RA would be return air temp. You could say RAT if you wanted. SA or SAT would be supply air temperature. Then you have your CSAT, which would be condenser saturation, also sometimes reflected as just CS. Then you have liquid line subcooling at LSC. And then you have your DSH, which is your discharge superheat. Yeah, so we see a high discharge superheat. Okay, so high discharge superheat also plays into a low charge example if we wanted to use that. So compressor's running hot, we're not cooling, we've got a low saturation on the evap and a high superheat coming back. So obviously, yeah, we've got some definite heat exchange problems going on. Um, so we see low charge. Okay, so we're talking through the low charge now and non-condensables. Okay, so non-condensables. Um, non-condensables is an interesting one. I didn't think of that one. Um, okay, so plenty of subcooling. All right, so now we're getting into TXV shutting down some. Touch really quick on discharge superheat. So discharge superheat, in a real short synopsis, it is the heat that is that your condenser has to de-superheat. One of the things that discharge superheat can help us determine is what's happening in the compressor. So if we start running excessive discharge superheats, it can help us identify if there is a problem, whether it be mechanical or electrical, or if it's just not getting cooled properly. So in this particular case, we have a suction superheat or an evaporator superheat of 30 degrees, which, because this compressor being a scroll is suction cooled, we're going to see that reflected in our discharge superheat, because 30 degrees is too high. That is an excessive number, and our compressor cannot cool itself properly with those values. So to get that calculation, you're going to take your discharge saturation or pressure, and then you're going to subtract from that the discharge line temperature within about 6 inches of the compressor. That'll give you your discharge superheat, very much as how you would take suction superheat with the suction line, get your suction saturation or evap sat, and then take your line temp. So just the inverse of that on the other end of the compressor. Um, okay, so yeah, I see TXV shutting down some. So let's finish off. I started with, do we have a low charge situation? We've got a lot of things that would tell us we do, except when we, and somebody pointed it out already, when we focus on our condenser saturation and liquid subcooling, if we truly had a charge problem, those two values would not be that elevated. Everything else could absolutely look like it does already, but those two values wouldn't be there. So we got 100 degrees. This is a standard modern system. I'm expecting 15-degree split on from the ambient to the condenser saturation, and so we're twice that. We're at 130, and I'm using a target of 8 to 12 on my liquid line subcooling. We're running 15, so we've got a little bit excessive liquid line subcooling. We've got a high condenser saturation, uh, um, but everything on the low side is low. So because of that, I would rule out a charge issue, because if my high side wasn't performing the way it was, then I that eliminates that from as a possibility. There's something else going on. So I see low charge. Okay, so Brad, we just talked out the low charge piece. Because of my high side readings, I can't. Yeah, this one, I wouldn't push this one into a low charge state. So what's the next alternative if we're not dealing with a low charge? See, failing TXV bulb, restricted, or kink on the liquid line. Okay, Joey, you've got some good points. Restricted, let's say, well, just anywhere in the liquid line is kind of where that's coming down to, whether it be at the TXV itself or back to the dryer. Um, we would see basically these symptoms. Yeah. So let's do that. Let's say we check our drop across the dryer. Drop on the dryer is 1 degree Fahrenheit. You did a visual inspection on the liquid line itself, and the liquid line inspection, just you couldn't find any visible kinks. Majority of the line set was accessible to some degree. Obviously, not everything is always going to be, but in this particular case, you were able to get there. You could not identify an actual kink. And by checking liquid line temperature at the condenser and liquid line temperature coming into the valve, you'd only lost maybe a 1 or 2 degrees. We got a fairly condensed line set here in this made up example. So um, there wasn't any severe loss across the liquid line, which would also help us indicate that we don't have a kink in the liquid line, because if we had one, I would have expected a more dramatic temperature loss from condenser to TXV. Um, let's see. I think either liquid line restriction or oil plug TXV failed, or superheat spring wound up too much, or low charge non-condensables. Maybe TXV screen plugged. Okay. All right. So yes, if we could start pushing in on the TXV itself. So ultimately, the TXV is a pretty strong culprit here. We're backing up on our condenser side. We're running low on the evaporator side. We're not keeping up with our with the heat in the space. So you have some options here. Now, and I did somewhat specifically choose this TXV. Now, this is not a practice that everybody uses, but I am a proponent, I think is the right word. I believe in um, calibrating and adjusting TXVs when it's appropriate. It should not be a first case scenario. You should really rule everything else out before you go to messing with the TXV. So in this particular case, um, what other conditions, before we just lock in on the TXV being the problem, what other conditions might cause this? I've seen non-condensables floating around. Um, I would expect my low side uh, saturation to be higher with the non-condensables. Um, I don't think it would pump. I don't think it would pull down that. I could correct me on that. Maybe I'm not remembering right. It's been a while since I've ran across one that had those conditions. Um, heck, I got a video on it. I guess I could go watch it. But in this particular case, these these aren't exactly what I would expect to see with non-condensables. And the low charge piece, we've rolled that out because our high side just has too much has too many things going on correctly, or just that are running high. So I expect my high side of the system to run low numbers, not high numbers. Um, let's see. I do see oil plug. So the evap being oil logged, for example, being oil logged on the evap. So a oil logged evap, I'm pretty sure that's what you're referring to. That would almost look like more of a low airflow. And my light turned off here. That would almost look like more of a low airflow condition with a uh, in that case. So I wouldn't expect that here, um, because the low airflow. When we get into low airflow, sorry, the light scattered me for a second. It's just not going to work. Okay, that's fine. I'm just going to be a little dark. Whatever. The low airflow, I would expect uh, low superheat. So my evaporator superheat is far too high to think that it could be some kind of oil logging issue or something along those lines. So I would remove that from the equation because of that. Now we could test that. So if you really thought, okay, I've got a oil log problem, um, a quick test for that you should be very careful with in the field is you manually cycle your condenser fan, and you're going to run your condenser head pressure higher artificially via the fan. Now, typically, what I recommend to my team, excuse me, whenever we do those kind of tests, I want them to run that head pressure between 120 and 130 degrees of saturation. Typically, that is enough to get the velocity and the line set high enough to force that oil to return. Um, so in this case, we're already there. We're already at the 130. I do see your clarification there, Sterling. You meant oil plug at the TXV inlet. It could be. Now, typically, when this would be another visual inspection that we could see. Usually when I see the actual TXV being plugged, whether it be at, or especially at the inlet screen, most of all, from that liquid line inlet port through the whole valve body will begin to frost and ice over in a way that it normally wouldn't. And I would expect the leaving side at the distributor going forward to be frosting up at this point with the way the system is running. So in this particular case, you go do a visual inspection at the TXV, and the TXV itself, the body is not freezing up. Excuse me. Um, it's just at the distributor going into the coil that you're having the freezing happening, and you're getting a little bit of frost on the body, but it's not happening at the inlet port where the screen would be. So that would be a visual inspection that you could do to confirm um, if the screen is causing a dramatic plug. Now that's not a actual solution to confirm that. It's still a very difficult diagnosis to make, but that's one of the things I would do and something I would expect to see. Okay, so sensing bulb loose or uninsulated, that is another kind of visual inspection. You check both of those, and the bulb is insulated, and you are satisfied with the mounting procedure they used. It's good and tight on the pipe. There's not a lot of corrosion around it. My preference is cork tape. I know not everybody appreciates that, but um, I do really like how well and how long cork tape holds up. I like it a lot better than the foam tape. I've had a lot of issues with foam tape. Um, so yes, the sensing bulb will roll out via visual inspection. It is okay. These are all excellent things. So you're all on the right track though. You're checking the right things. These are the steps you go through. The very last part of that process is we're going to open the stem up and start playing with the valve springs. So Joey says wrong refrigerant. Um, well, I okay. So let's say it was wrong refrigerant. Then the test procedure for that would be a standing saturation. So really the best thing you could do, in my opinion, would be to recover the charge out, or at least take enough of it out into a small recovery bottle to get some actual liquid in the system. Let that bottle equalize to ambient, and then on the vapor port on top of the recovery cylinder, you're going to check that bottle to whatever the ambient temperature is, not in the sunlight. So wherever you put the bottle to equalize that would need to be in the shade or inside of a building or something somewhere. So at that point, um, you would, yeah, you would expect to see your saturation to be right on point with a PT chart. If it's not, and you see that it equalizes to a um, significantly different saturation, then yes, that could either be non-condensables, which usually you're going to see a higher saturation, or it could just be a wrong refrigerant altogether. That would be one way, or maybe somebody mixed refrigerants they shouldn't have mixed. That does happen, especially with the drop-in stuff. There are quite a few people that believe drop-in means literally put on top of, um, and you can have a scenario like that. That's a good point. That's not something we typically think about, Joey. I sure don't. In this particular case, okay. So let's summarize that. Then this will solve our non-condensable question as well. So let's say we did that process. We recovered several pounds out. We partially filled up a recovery cylinder. We took it inside and put it in a closet. Came back an hour later or 30 minutes. Gave it plenty of time. Um, and then we compared what the ambient on the closet was to the saturation. Everything was on point. There was no issues. So we just took that refrigerant, we put that back in the system, but we're still having these numbers. That is it's a pretty good test, honestly. So um, let's see. Just kind of catching up on the chat here. So return error humidity. Return humidity in this particular case, I'm going to say it's running about 60%, 65% humidity. A customer said it's been struggling like this for maybe about a week, or it's been within the last week that they noticed it was uncomfortable. Okay. So at this point, we've ruled out a lot of options. I don't think we need to spend more time on it. Let's dive into the valve. There are some other things we need to check. Like I said, over undercharge, the actual physical components of the valve, the physical components of the system, the dryer, the non-condensables, refrigerant. We've gone through a whole checklist of items, and really we're down to what else could it be other than something with a TXV. So we take the cap off the stem. So in that TXV, as the stem is threaded in a clockwise direction, we're increasing spring pressure, which is going to increase our superheat. And the more we come out of that stem, we're going to decrease spring pressure, which allows it to open more and decrease our superheat. So in this particular case, we have a high superheat value, and we want to decrease that superheat. So you went in and let's say you did 2 full revolutions out on the valve, and you sit there. Now at this point, you're going to give the whole system roughly at least 20 minutes, 15, 20 minutes. I also recommend as much as, possibly 30. Really, if you wanted a more scientific way of knowing when is a good time, one great thing about the Bluetooth probes, I know for sure Testo, and I'm pretty confident Philpiece has this as well. You can graph the readings. So if you're graphing your your evap saturation and your superheat, then when that graph settles out and it stops kind of swinging up and down dramatically, which you'll see it do, that's when you know you've actually gotten a good flat line on your superheat at the valve with the new adjustment. Sometimes, depending on how big the system is and just the condition of it, it can take a lot longer than that. Sometimes it is easier just to completely shut the compressor off, let the system equalize, then let it turn back on after it's equalized. So if you have trouble getting it to stabilize after you make an adjustment, you might consider just cycling the compressor, allowing for that equalization to happen. In this particular case, so yes, we gum out 2 revolutions, we give it 20 minutes. Our graphing on the app shows we're stable. And yeah, I'll say that let's just by chance, two revolutions was the correct call. We're back up at about 40 degrees of saturation. That's going to bring us back down to about 10 degrees of superheat. We see our condenser saturation begin to fall back down. We're still going to run a little elevated because we have a high load in the space, but as that load pulls down, you'll see that saturation come down more. Our discharge superheat also begins to fall as we get our superheat under control, and our liquid line subcooling also comes down a little. Our supply air temperature also begins to drop down into the 50s. Now, essentially what we did is we'd made a slight calibration adjustment on the valve, and that got it to where it's now operating within the range we wanted it to. And in some cases, when you start dealing with this issue, um, you may see a dramatic result like this within 1 revolution. You may not even have to go a full 2. So there's a couple of things here. So at this stage, we've made a good call. TXV had an adjustment issue. We made that adjustment issue, or we made a adjustment and it's doing better. But I would caution you here. Depending on the age of the valve and the condition of the system, if it just recently started doing this, they haven't had somebody working on this system for some time, uh, there may be other things going on, such as the internals of that valve could be sticking, so they may be in the early stages of a failure. And that's part of what happened, in this particular case by us actuating the spring, and we changed things enough internally that um, it allowed it to break free. So basically, the push rod stem that's in there that the power head pushes against was able to actually come loose, and now it's fluctuating again like it needs to. I've had in some of these cases, I've done this. I've loosened it off. That stem broke loose. It began actuating, and I ended up basically having to putting it back where I started because the issue wasn't a bad adjustment. The issue ended up being it was frozen internally, and I just happened to do it at a time where it was capable of coming loose. So that should be something we think about. It could also be some kind of trash or debris getting into it. Now we have a screen that should correct for that, but stuff still gets through. Um, anyway, that was the actual charge that I had planned, or the diagnosis. I mean, was it was underfeeding valve. You get into steps of what do you do about the valve now? Is it actually a valve problem? Was it just a fluke? Was it never calibrated right to begin with? Where does that go? That's a different conversation. Um, why messing with a valve if only a problem for a week? How old is system? Has someone else been there? Okay, so Brad, so you're on the exact line of questioning that you should be. So this is where this one reason why I say saving the valve till the very end. It should be the very last thing you need to touch. And part of that is that's also why you should always count your revolutions. With anything that you do, you want to make sure you count where you were so that you can always put it back. And yes, I would have concerns if it starts to function the way I wanted it to after I adjusted it, but it's been an existing system with no other dramatic, like they haven't had compressors, they haven't had anything dramatic happen. What's going on now? Why did that valve stick internally? Because that's what it would tell me is something stuck. If it worked like it was supposed to for all these years and now all of a sudden like this happens, something happened. It doesn't mean the valve needs replaced, but we need to start asking more questions, and that is the right questions to ask. Okay. If any other questions on that example, feel free to jump them in. I am going to get the next example pulled up. So I got one more prepped here. Okay. This is the next example. Um, the complaint. The complaint is it is uncomfortable. It has been for last couple of weeks. We're not really sure what's going on. Please help us. But we're really uncomfortable. So kind of the same scenario. We got to pick somewhere, start with something. Uh, how do we make sense of this? Why are they so uncomfortable? Um, there's one specific thing that really stands out as kind of odd in this case. Um, okay, so Brad, outside air infiltration. That's a good one. It could be. Um, for the most part, let's just say this particular unit, it doesn't have a direct outside air drop or supply line coming into the return. So it's not directly pulling in outside air itself. And there's no gaping holes anywhere. Granted, old windows, bad doors, there's a lot of things that'll cause that infiltration. So for the most part, let's just assume that there's possibly something else going on, because welcome your input, or if what input anybody has on it. But let's not jump to that one at the gate, if that makes sense. Let's try to verify the rest of the system first. Uh, so yeah, we see evap saturation 45. I mean, what's wrong with that? Evap superheat is 10. Okay, so James, you're picking up on it. Evap sat is not too high. So that's the thing. Evap saturation is not too high, but it is higher than a lot of systems would normally run. I'll agree with that, but I wouldn't call it too high. It's not excessive. Our condenser saturation is 115. I mean, we're at that 15-degree split. Like I said, this is a standard system, nothing fancy. 10-degree subcool, 40-degree discharge superheat, perfectly fine with that. Which makes sense because our superheat is 10, so I wouldn't expect us to have any kind of discharge superheat issues with a 10-degree suction superheat. Let's see. Wonder if there's a duct connection issue. The ESET isn't terrible, too subtle. This one is a bit subtle, and there's some things I didn't give you here because I wanted to see if y'all could ask the right questions. So duct connection issue. You go do an inspection. Let's say this is uh, you go do an inspection of the duct wherever it's at. Whether you're looking at this as a light commercial, you got a drop ceiling, or whether you've got an attic, either or. Um, so no obvious issues with the duct. Everything looks tight. Nothing just blatantly blowing out anywhere that you can tell. See, outside air is 100. 58 supply air isn't bad. Well, supply air isn't dictated on outside air. We have a return air of 72, and that should tell you something as well. If they're uncomfortable, is the system dehumidifying? That's a good question. Is it dehumidifying? What is the discomfort? They've got 72 return air. Again, that's a good question. What at 72 degrees, in the space, why would that be uncomfortable, or why would they be having issues? That is a good question. Could be oversized, as in the system. Um, yeah, yes, yes. Well, I say yes. It could be, yeah, but there's something more specific that is affecting this, and you can tell by the temperature readings. Um, so discomfort from humidity. Well, that's where we have to come in. So they don't know how to articulate that most of the time. So is it from humidity? Well, we have to determine that. Um, need to lower blower speed. Okay. Why? Why do you want to lower the blower speed? I'm not trying to be elementary or nothing. Let's keep the conversation. So what is the runtime? What is a new issue? Runtime. The unit's been running like this for a couple of weeks. Oh, by the way, we had somebody out here, different company, doing some work on it, regular seasonal stuff. They had just had a cheapest contract bidder. They came out, washed the coils, did some stuff upstairs, but it's just been a little weird ever since then. We've not been able to get them to come back since they were here. I see an oversized. Yeah, I bet you that runtime is too short and the system is not dehumidifying, therefore uncomfortable or the blower speed. Too much airflow, insufficient, insufficient compressor. Uh, sorry. I have gotten you a couple of times on that, haven't I? No, this is not. I'll just tell you this one up front. It's not an inefficient compressor. Low delta T. Yes, it is a low delta T. Lower the indoor speed so we can condensate more humidity. Yes. Okay. Ultimately, yeah, you're I tell them to call. Yeah. Well, they tried to call. So let's say this happens. They tried to call the previous company, and they said they're weeks out. They can't get there. They'll just have to deal with it. Whether that's true or not, it's irrelevant. It's just that's what they were told, and they need this corrected now. They've already been waiting a couple of weeks and trying to deal with this. All right. So return air humidity, let's say, is between 65 and 70% relative humidity in the return and down in the space. So, and yes, um, the cycle time seems a little short. It just is running different than it was. They most of the time we rarely get feedback any better than that. Um, so we see TXV overfeeding. TXV overfeeding because of a bulb issue, because our superheat is maintaining okay, I would say more than likely not. So yeah, let's say you get up there, you've got these readings, everything for the most part actually looks okay, except for two numbers. We have a low return air, we have a high supply air. That differential is quite low. And they're still complaining of being uncomfortable. We get our psychrometer out. Psychrometer tells us we're running pretty high on humidity. We get up into the attic and we start looking at the air handler. In that process, we see the blower was set up on high speed. It was, whether it was recently moved, just whatever the case may be, it was set up on high speed on the blower. So you end up taking, and uh, the next call would be well, let's lower that fan speed down. That's been mentioned a couple of times here. We're going to lower the fan speed. I would recommend, typically I start at medium, see how we do. And if I still see that we're running higher saturation, so 45, yeah, if it's a house that's going to deal with humidity issues, and if they do have infiltration problems, then we're going to have more humidity than we normally would to deal with. So I wouldn't want a 45-degree coil in a space like that. I'd much rather see that much lower down. Um, let's see. And so yeah, we drop it to medium. Let's say we come down to 42 or 43 saturation. Our superheat maintains, subcooling maintains, everything else pretty well maintains, except we lower saturation and we drop our supply air from 58 to, let's say, 56 by lowering the speed by one notch, if you will. So they could run like that, and that would honestly be probably a wise suggestion. Is by slowing the fan down one notch. We don't want to overshoot. We don't want to cause a problem where they can't keep up because of saturation, because of sensible. So if we lower it, if we go too slow on the fan, we could get to a place where the system always runs, it over dehumidifies, where it just dries it out too much. And then they may even have an issue where the system it won't even keep up in some cases. So it'll just run all day almost and just might not ever make set point during the day. So that's the consequence of going too far. So I would suggest take it slow, take them one notch, tell them, hey, give it 24 to 48 hours. Let's let it run here. Let's see how it does. If you feel comfortable and you're happy with it, then we'll call it good. I don't need to come back. If you're still not quite happy with it, or if you want me to return anyway, then we can come back. I can take some more humidity readings, and if we're still seeing after that time frame that they're running higher than or higher than 60% humidity, and we still don't see quite what we're looking for, then I would suggest, dropping that down to that low speed. And there are some systems that they, because of the humidity issues in the space and just the overall design of it, they do run the blower at low speed, even in cooling mode. So don't let that be just an automatic, well, that's only for heating or such, because I've heard that before. Um, it really depends on the whole system's design, application, install, everything. So anyway, let's say that that did happen. Let's just say that they gave it 24 hours. They called you back and they said, "Hey, you know what? It's better, but it's still not quite the same. I don't know what's going on here." And so you go back out there, you see the new readings. The return error is they've kept the return about the same because they're running the thermostat at 71, 70, or at 72 in this particular case. Let's say the thermostat's set at 72. They're still uncomfortable. It's not quite where they want to be. You know how picky people can be. So you end up dropping from medium speed to low speed. That gets our evap saturation down between 38 and 40. Superheat still maintains at 10, being a TXV, no issue there. The rest of the system still maintains where it's at, no issues there. But our supply air now drops even further to where we're pushing out, say, around 53, 54 degrees once we stabilize. So at that point, we're pulling out a lot more humidity. And for me, if that was me in this case, it would be a reasonable assumption that uh, the company that came out and did the prior inspection, maybe their technicians just weren't as experienced or as well trained, whatever the case may be. So they saw the low speed on the fan during the inspection. Technician, from the training he's had, thought he was doing a good thing. He thought he was helping them because he was taught a rule of thumb that cooling speed, or for cooling mode, the fan should always be set to high, and you're going to get your best performance in that state. So he that's what he did. He moved the fan from low. It was originally on low. He moved it to high, thinking that that was going to make it work better. And he thought that he did. But in reality, he created a humidity problem that didn't have to be there. So those are that's a fairly realistic scenario, in my opinion. That just, yeah, we got to be careful with the rule of thumbs. But yes, in this particular case, I designed this scenario to be a high fan speed diagnosis with causing high humidity, the humidity being the symptom. So by lowering that fan speed, we're slowing the air down, we're processing it better, getting the humidity out, and the customer's perfectly happy at that stage. Um, yeah, good job, guys. Okay, well, those are the two examples I had planned for today. Um, we are doing pretty good on time. I'll spend some time kind of reading through the comments here, and any other questions that you have, go ahead and start getting those in, and let's finish up the conversation before everybody's got to get back to work. Let's see. Too high humidity could be runtime, airflow, maybe condensate not draining properly or blowing. Oh, so Sterling, that actually is a pretty good point. Um, in some cases, especially if the P-trap is not done properly, I didn't even think to cover that. Whether it be a P-trap or a drainage issue or a crack um, in the drain pan, or if you've got a system where the duct wasn't sized very well and you end up having really high velocity because maybe it's a little too small, then that airstream at a high fan speed can cause the moisture to wick off of the coil and never even make it to the drain pan. So you end up literally just your refrigerant condenses it, and then the airstream just sucks it right back into itself, and it carries it on downstream. So that could be a real issue there. So yes, make sure your condensates and all that are in good shape and are properly installed. Uh, there's a lot of condensation. Is the suction line sweating more than usual? If that's the case, the system is not dehumidifying. But you're saying the blower is too fast. Yep. Slow the fan down. Yes. Excellent. Actually ran across something like this. It was almost 2 months. It was a 2 month system. Carrier communicating infinity. Return air 74 with a 50%. My supply was 72%. Ah, yeah. Let's see. At that point, probably evil spirits. Yeah, moving latent heat too. Yep. What if the last tech claimed, or what if the last tech had cleaned the evap? Cause that? Okay, so that's a pretty good point. So let's say he didn't move the fan speed. Let's say the coil was really dirty. Maybe somebody in the past had moved the fan speed to overcome the dirty coil. He had cleaned it, which is not something you would be able to identify, or maybe you could. Maybe he left some evidence or something behind. Either way, or maybe he told them, "Hey, I cleaned your coil." Um, that's pretty realistic. No, I like that. It's a good point. Maybe they cleaned the coil and they didn't properly check the system after they did. Uh, high oil temp on RTAA. RTAA oil temps. Well, if you're running low, so I think the safety is 180. It's either 170 or 180 on the trip out. So if you're running high temperatures, it's a good indication that you're low, or you've got a condenser coil or condenser fan issue. Um, for those, I've seen a lot of times where it may not be super obvious that there's a coil issue or the coil's dirty, I mean, and the whole top section of that coil for those condenser coils are the oil cooling circuit. So it's imperative that that higher end of the coil is really clean for that purpose. So those would be the three things I'd want to look into. What's my oil level doing? What's my uh how clean is the coil? And if you're not confident, go ahead and clean it. Even if you just do that top section, just clean the coil, and or make sure all your condenser fans are all spinning and functioning and spinning the right way. Uh, you'd be you'd be surprised how many fans I've seen run in the wrong direction over the years. Uh, let's see. Are there any more classes that I can watch? We're doing these every 2 weeks. This is something we've done. I guess this is our second one, or second, third, something like that, where it's just a full on example like this. So there's been a couple of them. If you go back and look at the past streams, all of these are via live stream like this. Um, Honestly, it seems like everybody's really appreciating this format, so we may keep this kind of thing going, at minimum through the summer. I don't know. So we have I've still got to need to get our training committee together and kind of figure out what some of our next long terms are going to be. Um, Question about screws. Could a stuck slider cause high discharge superheat with no other symptoms? No high head. Evap superheat is good. Everything else seems normal. No. No is the short answer. Mm. Yeah, so the slide valve being stuck, if it's stuck um, if it's stuck too high, then you're going to be running elevated head pressures. Now, granted, if your outside ambient isn't that high, then your condenser fans may be able to stage enough to kind of mitigate that some. It also kind of depends on which compressor you're dealing with, whether you're dealing with like a train C&N or CHH, or we're talking a screw or a York, Daikin, carrier screw. Each one of those have a couple of different things that are somewhat unique to them that can kind of convolute that answer. But ultimately, if it's a Bitzer, okay, so Bitzer, well then yeah, so it doesn't have any other internals. Okay, well ultimately, if your evap superheat is maintaining, you're not having head pressure issues, your evap saturation seems fine, but you're running elevated discharge superheat, it could be an oil issue. The oil is extremely critical to those compressors. It could also be a power issue. I don't know if maybe you're having a phasing problem. So just something could be going on in the winding. Maybe running, maybe you ought to meg the motors at some point and see what your maker's doing. Because if that stator is starting to get weak, maybe you're starting to get a trickle to ground, not enough to trip the overloads, but you may see elevated amp draws. That's going to be an indication that something's happening internally, or maybe your starter contacts are getting really worn. That's going to cause extra heat in the winding, which is going to be reflected in your discharge superheat. Okay. Yeah. All right, guys. Well, hope everybody enjoyed it. Um, hope this format wasn't too weird. Like I said, I'm just working a remote today, trying to get some stuff caught up. I got too many things not done that I got to get done. So, um, with that, I'll see y'all around. All my APS guys, I'll see y'all out in the field. Y'all stay safe, drink your water, stay hydrated, and take care of yourselves, please.